Do that now. All right. I would like to start off and thank everyone for taking the time to attend today. Hello, my name is Lance Zurich, and I am the product manager for the Fischertechnik Education Division over here at Studica. And today I'm going to provide you with an overview of Fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in CTE training, if you're a college professor or an industrial trainer teaching programming skills required in manufacturing, or if you're a company looking for ways to demonstrate their software-based solutions, or even just someone looking for ways to make IoT-related concepts easier to understand to employees or customers, in any of these cases, I believe this presentation will offer some important options for you to consider. Let's start off by considering the skills gap. Now, if you've attended any of our other Fischertechnik education webinars, you probably heard me discuss the importance of STEM education. Now, STEM, of course, is the acronym for science, technology, engineering, and mathematics. And at this point, it really should go without saying that STEM education has been perhaps the most discussed topic in education for the last decade, and it continues to remain so. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help them best prepare to take their place in the modern workforce. Now, not so long ago when our parents, or let's say our grandparents, were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. Now, as it ties in directly with the solutions we will be looking at in this presentation, let's consider the last skill area I just touched on, that of a PLC programmer. Now, first off, for anyone who may not be familiar, let me explain exactly what a PLC is. The term PLC is an acronym, just like STEM. The letters in this case which stand for Programmable Logic Controller. Essentially, a Programmable Logic Controller, or PLC, is a very specialized computer used to control the types of machines and automated processes typically found in an industrial setting, things such as an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. To get a clear idea of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, "The average PLC programmer salary in the USA is $78,000 per year, or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year," end quote. In fact, a quick glance at the first page of recent job openings for PLC programmers on Nuvu for the date of February 27th, 2020 showed 15 positions being advertised with salaries over $75,000. Now, 2 of these actually listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. Now, at the same time as this workforce of tomorrow gets their training, more and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools offering such programs. So how long does it take to learn? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient in all 5 of the most widely used PLC programming languages listed here, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more training time is required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are many other options available. There could be college, of course, college and university programs, but there's also high school CTE or career and technical education programs. There are adult continuing education programs, vocational training of various sorts, technical training in trade schools, and employer-sponsored incumbent worker training programs. Now, this all being said, the question that still arises for the educator, whether they're in the university or the vocational school classroom, is how do you go about teaching PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it more realistic and hands-on? But there are other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be a company involved in creating or marketing a new type of software-based solution that's looking for ways to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's a company looking for an engaging way to demonstrate their services or solutions in a public setting such as a trade show. In each of these cases, and many more, there is a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of Fischertechnik industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. Now, the line consists of a series of pre-assembled small-scale models, which are designed to replicate both in appearance and function various automated robotic machines and systems commonly used in commercial manufacturing. But before we look at each of these models, let me provide you with just a little bit of background on what Fischertechnik is. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, based around their unique building system. Now, what makes their building system unique is that unlike other popular construction systems where the components are designed to simply stack, with the Fischertechnik system, it was all created with more of an engineering mindset. The core building block in the system is designed to enable attachment from all 6 sides, and thus it allows for almost limitless design possibilities. Now, many of the parts are designed to slide together and lock in place, and the hundreds of different parts that are available also will help to address very specific design needs. The Fischertechnik system was developed back in the 1960s by German inventor Arthur Fischer, who's also noted for countless innovations used in the construction and automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, and that was back in 1949, as well as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. I'm sure we've all used them or seen them. Now, his company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction. And they also produce numerous components used in the automobile assembly process, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of Fischertechnik sets, now whether those would be the sets intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology. Many of the products offered by Fischertechnik for the education sector are subject-specific sets focusing on different STEM-related topic areas. This would be things like mechanics, pneumatics, robotics, or even renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique Fischertechnik system, and then perform various experiments which allow them to explore and understand aspects of that subject. Now, there are also sets designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based programs, students dive deep into engineering and learn all aspects of the design process, which requires them to work in groups and create various devices and automated machines to meet the criteria put forth in a series of real-world scenarios based upon their own trial and error, experimentation, and research. Now, getting back to the line of Fischertechnik simulation solutions, which are, of course, the focus of today's presentation, these are something much different. The line itself consists not of kits, but of a series of pre-assembled, small-scale models, which replicate, once again, in appearance and function, various automated robotic machines and systems. Models in the Fischertechnik simulation line include things such as conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, Fischertechnik also offers an integrated factory simulation model. And this factory simulation model consists of 4 individual workstations, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, which all work together as one self-contained material cycle. But before we begin to look at the models in the simulation line in more detail, let me briefly outline some of the advantages of using Fischertechnik solutions. Now, I'm going to apologize in advance as the first few points are things I've already mentioned, but I think in each case it's worth repeating. First, Fischertechnik simulation solutions offer educators or allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programmable or PLC-focused learning environment. Advantage 2. The models, once again, are designed to realistically replicate, in both appearance and in function, common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases tabletop sized, they are not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. Another aspect is quality. Each Fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each model, with one exception that I will address a little bit later, is currently available in 2 different versions. The first version is a 24-volt version, which is designed for use with industry-standard PLCs. Now, whether you use Allen Bradley controllers, Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or many others, you can control these 24-volt Fischertechnik versions with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language from the methods listed on the screen now. Please note, though, that with the 24-volt versions, no PLC is included, and all programming and programming guidance, as well as any other power sources or other hardware, are the responsibility of the end user. Of course, this shouldn't be an issue, as these models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. On the other hand, for non-industrial users or for educators not versed in or familiar with PLC programming, there are also 9-volt versions of each model which are available. Now, these 9-volt versions ship pre-wired to Fischertechnik's own proprietary robotic controllers, which are called the Robotics TXT controller, and each of these controllers is pre-programmed using Fischertechnik's own RoboPro graphic programming software. Now, with these 9-volt versions, the only additional component required will be the addition of 1 or more 120-volt power adapters as specified with each model. Otherwise, in most cases, these 9-volt models should be ready to use out of the box. Now, if you're involved in demonstrating or exploring IoT, of course, the Internet of Things, Besides the fact that many end users have adopted many of the models in the primary line of simulation and training solutions for IoT purposes, Fischertechnik also offers a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud control and what is sometimes referred to as Factory 4.0. Now, in this case, the model is designed to be both controlled and monitored from a special web-based dashboard. We will, of course, discuss this in more detail a bit later in the presentation. Finally, Fischertechnik simulation models are cost-effective. While I'm not going to name names, I will say that if you have ever looked in any of the other hardware-based industrial simulation options that are available in the marketplace, you'll probably notice that the entry point for many of these products can easily be $20,000 to $30,000 or even much more. Fischertechnik simulation solutions, on the other hand, are only a fraction of that price, as well as being compact, realistic, and high-quality learning and demonstration tools. So on that note, let's take a look at each of the models which are currently available. The first up is the vacuum gripper robot. Let the video catch up a little bit here. Hang on a second. We will get this working for you, so don't go anywhere. Okay, this is a little bit smoother. Thanks for hanging in there. Once again, we're going to be looking at the vacuum gripper robot. Now, as you can see, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position work pieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you see in the video when you look at the model, and a solenoid valve. The dimensions of this model are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds. The 24-volt versions of this model, as well as all of the other 24-volt models that we will discuss today, each have a relay board for motor polarity reversal and both a multi-pin connector, 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as with all of the 24-volt versions, will require you to provide the PLC and the programming. The 9-volt version, which is the version that you see being used in this video, will once again come pre-wired to the Fischertechnik Robotic TXT controller and will ship fully programmed using RoboPro graphic programming software. Now, if you wish to create your own programming, individual licenses of RoboPro are available on our website. Otherwise, for this 9-volt version, only the addition of a single 120-volt power adapter will be required. I will mention that for this and for all the other models we're going to look at today, the specs are also detailed in the product listings found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. I know we're lagging a little bit here. We're getting a little bit of jumping. So we're going to go to the next screen. Next, we're going to look at the automated high bay warehouse, and hopefully we're a little more fluid this time. Okay. The model shown here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, and 9 individual storage spots. Components on this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each. I do apologize for the choppiness we're having here right now. I'm not sure exactly why we're having it. Bear with me a second. Get this back on track here. Now I will note, okay, now that we're moving along a little better, that this model is a favorite among educators I know who teach programming. And the reason for that is because it gives you a lot to work with, at least as regards to the movements of the picker mechanism, as well as the precision, excuse me, as well as the precision required to properly store and retrieve each of these work pieces. Each step, of course, which will require its own specific coding. So as far as for programming, a lot for students to work with here, a lot of tasks to work on, a lot of difficulty, and that's all good. The dimensions for this model are approximately 19 by 28.5 by 15 inches with a weight of approximately 18 pounds. Now, once again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, you're going to need provide your own PLC and programming. And the 9-volt version is once again pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is required. So the next model in the line is the multi-processing station with oven simulation. Now the model we see here features a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 phototransistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches with a weight of about 11 pounds. Again, this is available in both 24-volt versions for use with the PLC of your choice, and the 9-volt version in this case is connected to 2 robotics TXT controllers. So in this case, 2 120-volt power adapters will be required for all operations. I actually got ahead of the video for once. Next, we're going to look at the sorting line with color detection. It likes to turn its sound on. Now, this simulation features a system for detecting work pieces of different colors and sorts them via a conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as with the models we've looked at before, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, you need to provide the PLC and the programming. The 9-volt version again comes pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is required. And we've got it all sorted out now. The next model is the factory simulation, which combines the 4 models we've just reviewed the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with the color detection, it combines all of these into one self-contained material cycle. The cycle works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with the oven. After the work piece has been processed by this machine, it is then sorted by color in the sorting line with color detection, before again being moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've already discussed the components of each model previously, I won't belabor it by restating them here. But what I do want to discuss are the dimensions of this model as a whole. As it again combines 4 individual models into one cycle, it has a much larger footprint, in this case approximately 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, depending on whether we're talking about the 24-volt version or the 9-volt version. Now, due to these dimensions, and because this model once again ships pre-assembled, please note that this model will only be shipped flat as freight on a pallet. I also want to point out that as the factory simulation models tend to be in high demand, please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. Now, a few other things to note. First, this is again available in both 24-volt and 9-volt versions. In this instance, the 9-volt version is wired to 5 robotics TXT controllers. But in this case, because of how it's wired together, because a few of them are daisy chained, it will require 3 120-volt power adapters. Now, as always, the 24-volt version will require the end user to provide all PLCs, all programming, and any other hardware required. Again, each station on the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. But jumping right along, before we move on to the next group of models, I do want to mention that there is a storage option available, as you see on your screen now, available for those users of either of the 2 factory simulations we just looked at, who may need to transport the model or who just want to protect the model when it's not in use. The travel case, shown here, consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in differing heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories that will be needed. The lower portion is lined with hard foam, and it is designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. This case has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of approximately 53 pounds on its own. That's without the model in it. Please note that even when using the travel case, these models will still need to be shipped flat. Unfortunately, our graphic shows it on its side. It will maybe only travel to you on its side, but once you put the model in it, once again, it has to lay flat. So moving right along, the next model is a basic conveyor belt. This is a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters each. Multiple conveyors can easily be connected to increase the length of the transport as desired. Components on this model include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions of this model are approximately 14 by 10 by 4 inches with a weight of under 2 pounds. As before, this is available in both a 24-volt version, as is shown on this screen, and also 9-volt versions connected to the robotics TXT controller as shown here. In this case, with the 9-volt version, one 120-volt power adapter is required for operation. The next model is a variation of the conveyor belt, which includes a punching machine. This features essentially the same conveyor as we just looked at, except that this time with a machining station built in. Components on this model include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. Dimensions on this particular model are approximately 15 by 12 by 7.5 inches, and it has a weight of about 3.5 pounds. Again, it's available in both a 24-volt variation, as shown in this picture, and a 9-volt version wired to the Robotics TXT controller, as shown here, which again requires 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. The model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts, as I just mentioned, 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions of this model are approximately 19 by 18 by 11 inches with a weight of about 8 pounds. Again, it's available in both the 24-volt version for use with a PLC and a 9-volt version wired to the pre-programmed Robotics TXT controllers and requiring one 120-volt power adapter because of the way they're daisy-chained here. Next is a variation on the idea of a pick-and-place robot, the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or backwards 90 millimeters. And axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions on this model are approximately 19 by 16 by 9 inches, and it has a weight of about 6 pounds. Now, as with the other models we've looked at, this is again available in both a 24-volt version for use with the PLC and programming of your choice, or a 9-volt version wired to a pre-programmed Robotics TXT controller, and again requiring one 120-volt power adapter. Now that concludes our look at the first 9 variations of simulation models, all of which are available currently in both 24-volt and 9-volt versions. The next simulation model is designed specifically to address the topic of cloud-based monitoring and control. This is the Training Factory Industry 4.0. Now this model is designed to help address how the recent changes in industrial production driven by digitization have created a need for stronger networking and more relevant information on all production levels. Now with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a larger scale. Now, as the following video provides a nicely narrated overview of how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The 6 Fischertechnik TXT controllers control the learning factory. The controllers communicate with each other via standard MQTT protocol. The controller programs are written in C, C++, and the controllers arrive with the programs already loaded on them so that they can be used right away. The programs can be changed and customized. The sensor image data are used and monitored in the Fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The high bay warehouse is organized chaotically. There is no fixed space for a material to be stored. The system simply recognizes the next available space. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. Fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. A customized storage and transport case is a worthwhile add-on.
Pretty impressive, I hope you agree. The following topics can be addressed with the Fischertechnik Training Factory Industry 4.0. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, and digital traceability with NFC/RFID technology. Customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, linking of production and materials planning data, connection of upstream and downstream logistics processes, and for experts, the creation of your own unique programming using C or C++. Now, as you just saw, this model incorporates many features not found in the models we've previously discussed, and besides just most notably, the use of a cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera attachment for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, enables the positions of each piece in the work cycle to be mapped. And the use of MQTT, message queuing telemetry transport, allows the network TXT controllers to communicate with each other. Now, as discussed, this model is currently available in 9-volt versions with the control facilitated through the use of 6 robotics TXT controllers. Now, unlike all the other 9-volt versions we've looked at previously, these are programmed not using RoboPro, but instead in this case using C, C++. Again, all of the programming for this model is preloaded so that once the connections to the internet and the cloud-based dashboards are made, all of which are clearly outlined in the downloadable documentation PDF, you should be able to get started quickly. Dimensions for this model are approximately 39 by 31 by 16 inches, and it has a total weight of approximately 53 pounds. The 9-volt version will require the addition of 3 120-volt power adapters, the ability to access the internet, as well as a tablet or device for accessing the cloud-based dashboard. Now, as with the 2 factory simulation models we discussed previously, we do recommend the travel case to help protect your model during transport and storage. Which, of course, may well beg the question, so what about the 24-volt version? The case here is that we actually expect the 24-volt version to be available for shipment probably within the next few weeks. We're still awaiting the final details on the model, as well as the final graphics for that. So once we get those, we will be altering upcoming presentations, and we will be posting all of the details on our website very shortly. So I do ask you to watch for that. Once again, we'll have pricing, we'll have availability, we'll have all of that very shortly. So just bear with us a week or two, and you should see something on the website. So in either case, that's the Training Factory Industry 4.0. Of course, you're probably wondering how much these models cost, since I made the remark about them being a fraction of the cost of the competing models. So let's take a quick review again of each option I've discussed, along with the pricing for each of them. We'll start with the vacuum gripper robot. The 24-volt version is available for $899 each, and the 9-volt version, again, pre-wired to the robotics TXT controller, which is pre-programmed, is $1,199 each. The automated high bay warehouse in the 24-volt version is $1,035. The 9-volt version, once again with the TXT controller controlling it, all pre-programmed, is $1,319. The multi-processing station with the oven in the 24-volt version, where you provide the programming and the PLC, is $989. In the 9-volt version, where we include the robotics TXT controller and the programming, it's $1,479. Sorting line with color detection, 24-volt version is $819. 9-volt version is $1,129. The factory simulation, in the 24-volt version, again, you supply the programming and the PLCs here, $3,729 each. The 9-volt version, pre-wired to, I believe that's 5 of the robotics TXT controllers. Again, this one is $5,239. Conveyor belt model, 24-volt version is $220 each, and the 9-volt version with the TXT controller is $519 each. Punching machine with conveyor belt in the 24-volt version is $289 each, and the 9-volt version is $599 each. Again, I think you can see a pattern. These are much cheaper than, as I mentioned, some of the models you'll see from some of the other manufacturers that are available. 3D robot, the pick and place robot. The 24-volt version is $829. The 9-volt version is $1,099. The indexed line with 2 machining stations, 24-volt version, $879, very affordable, and the 9-volt version, $1,399. The Training Factory Industry 4.0. Again, I will have more details on the 24-volt version and the pricing. That will be very shortly. The 9-volt version, pre-wired to the robotics TXT controllers, in this case programmed with C, C++, $6,495 each. These are in very high demand, so if this is something you would be interested in getting, I would ask you to contact us as soon as you can. Other items that have come up in the presentation, as I mentioned several times, pertain to the 9-volt models. You may need one or more 120-volt power adapters. Those are just $12.99 each. The travel and storage case, which is used for both factory simulation models, as well as both of the Training Factory Industry 4.0 models, both the 9-volt version that's currently available and the 24-volt version that we'll have details on, like I said, literally any day. It works for all of those. Those are $1,000 each. So at this point, I should probably open things up for any questions. So once again, there are 2 ways to ask questions. You could use either of the chat windows that we have. We have a Zoom webinar chat window again. It's located, it should be located under the ellipses on the Zoom toolbar. You can click on that and you can type in any question you might have. The other way you can ask is there should also be on the toolbar a little question and answer icon that you can click on. And if you have any questions, you can type them right in that box and I will do my best to address them. So again, if you have any questions, I will also mention when I go to the next screen, you'll have email addresses and contact information. So if you do want to contact us, either if you want to contact the company about possibly getting a quote or finding out more information, you can do that. If you have any questions about anything specifically that I have mentioned during the presentation, you will have my email address as well, and you can email me directly about that. Just to, since I see no questions coming up, let's move right along to that. We're sticking. Oh. Bear with me a second here. Okay, there we go. Boom. Skipped right past it. Taking the next step. If you would like to request a full color brochure or current pricing, if you would like to ask any questions directly, if you'd like to receive a quote, or if you want to speak to your dedicated educational representative, there are many people besides myself here. You can call us directly. Our number is Studica US is 888-561-7521. That's a toll-free number, of course, in the United States, 888-561-7521. If you have general questions or you need a quote or what have you, you can email info@studica.com, mention the training models, and you can ask away. You can also email me directly. Any questions you might have about any of the aspects of anything Fischertechnik, anything I've discussed specifically here today, you can email me, lance.zurek, lance.zurek @Studica, studica.com. So I will leave that up for just a second. Once again, if you need to copy anything down, it's right there. We will also send a follow-up email, I believe, usually with a link to a recording of this webinar if you'd like to review it or if you have any other questions. On that note, I would like to say thank you very much for taking the time to attend today's presentation. I know it's hard to make time these days, so I do thank you very much, and we look forward to hearing from you soon. Take care and have a great afternoon.